This example shows an air intake assembly, and the engineer wants to optimize the geometry for the duct because the existing duct is very restrictive, producing low manifold pressure at the throttle body. The objective here is to minimize manifold pressure while staying within dimensional limits for both physical positioning and manufacturing. The duct geometry has been parameterized to control the length, girth, and bend radius. The fluid volume is then of course based on the part geometry. And here we show the CFD model for the duct in the original design, including boundary conditions. Flow results of the initial design show an excessive manifold pressure loss of over 3 inches of water. Because of NXCAE's powerful geometry foundation, it's possible to run optimization routines using the geometry parameters directly as design variables. So the engineer here first defines the optimization objective, which is to minimize the absolute value of average total pressure at the throttle body. For the design variables, the engineer selects the parameters that were defined earlier and enters the appropriate limits that reflect geometric and manufacturing considerations. Once the optimization solution is defined, NXCAE will perform multiple iterations of the same solution, where it will first change the design variables based on the solution results. And since the analysis model is associated to the geometry, it updates the CFD model automatically and reruns the solution. It will iterate on this until it converges on a solution. NXCAE generates an optimization spreadsheet with tables and graphs for manifold pressure loss and each design variable for validation. And of course the engineer can graphically view the results and see the resulting geometry. But the key point of this example is to show that simulation-driven design is not a dream, and can be achieved today with a modern simulation environment.